All right, so this morning I'd like to talk about multiplying and dividing integers. And how do we do that? How do we go about that? What does it mean to multiply integers? So let's start off with what we're comfortable with, positive numbers. So if I was to look at positive 2 times positive 5, one way of thinking about that is that's two groups of positive 5. And two groups of positive 5 would be positive 10. So what about if we looked at the next one here, where we had positive 2 times negative 5? Well, again, remember the reds represent negatives, so we could think of this as two groups of negative 5, and two groups of negative 5. It's like negative 5 plus negative 5, of course, is negative 10. Now, this is where it gets a little tricky. Negative 2 times 5. We're not quite sure what it means to have negative 2 groups of 5. But we use a property of multiplication which says you can change the order around. 3 times 4 is the same as 4 times 3. So negative 2 times 5 should be the same as 5 times negative 2. And 5 times negative 2, well, here's 5 groups of negative 2. That's equal to negative 10. So here's a different way of thinking about this. Remember, negative 2 is really the opposite of 2. So we could think of this as the opposite of two groups of 5. Well, two groups of 5 is 10. So the opposite of 10, and of course the opposite of 10 is negative 10. So if we think of it that way, then when I get down to this one, where I have negative 2 times negative 5, I could think of this as the opposite of two groups of negative 5, and two groups of negative 5 is, as we found out above there, two groups of negative 5 is negative 10. So what's the opposite of negative 10? Well, it's positive 10. So if we look, a positive times a positive is positive. A positive times a negative is negative. A negative times a positive is negative. And a negative and a negative are positive. Now that's kind of hard to remember, so I summarize it this way. I say when you multiply two numbers together, if the signs are the same, the result's positive. Which means, of course, if the signs aren't the same, the result will be negative. Okay? So if we go into a question like this then, negative 3 times negative 2, or sorry, negative 1 times 3 times negative 2 times negative 4. Well, we do the multiplication. Since it's all multiplication, we do it from left to right. So negative 1 times positive 3, well, 3 times 1 is 3. Since the signs are different, this is going to be a negative. Negative 3 and negative 2, 2 times 3 is 6. Since the signs are the same, the result is positive. 6 times 4 is 24. Since the signs are different, the result is negative. Now what you'll notice is in that one there were three negative numbers, and notice the result was negative. Now, one tricky question. What happens when I have negative 12 times 0 times negative 21 times 4? And if you recognize 0, when I multiply any number by 0, the result is always 0. So you don't have to do any work with this question. When there's a 0 in there, the result is 0. All right, well, now we go back and we revisit exponents again. Here I have negative 3 squared. Remember, this really means negative 3 times negative 3. Well, since the 3 times 3 is 9, since the signs are the same, the result's positive, so we should get a positive 9. Now here, let me change colors here and tell you, beware. You have to be very careful. And remember some of our terminology. Here, back here, I would say negative 3 is the base, and 2 is the exponent. Turns out in this next one, well, just the way I wrote it, it would not mean this. Here, 3 is the base, and 2 is the exponent. Okay, and that minus sign is actually just telling me to take the opposite of. So you can think of this as the opposite of 3 squared. Well, 3 squared, 3 times 3 is 9, and I want the opposite of that, minus 9. The big difference between those two is in the first one, negative 3 was part of the base because of the bracket. When there's no bracket, order of operations says you do the power first. The base would be considered just positive 3. So beware, you're going to get one like that on your exam. So make sure you're real comfortable with that. So lastly, now we throw you all the operations together. And this is where I said things start to get confusing, right? Remember your order of operations. Order of operations holds all the time when there's more than one operation, one kind of operation within a number sentence. So if I was to look here, I have 7 minus 2 times. Now, how do you know it's times? Well, when there's a number and then a bracket with nothing in between them, it's always a times. So positive 7 times minus 2 times 3 squared minus 4 times 5. So order of operations says we would start off with any operations in the brackets. So I'm going to start with the brackets. So I'm going to leave this. And that's the mistake that most students make. They want to do that subtraction first. It shouldn't be done first. It is one of the last operations we do. So within the brackets, what do you do first? Well, we do exponents first. So we got to do 3 squared. Now remember, 3 squared, not 3 times 2. It's 3 times itself, twice. 3 times 3. So that's 9. Okay, and I just do one operation at a time so I don't get confused. So 7 minus 2. Now within the bracket, the next thing I have a subtraction and a multiplication. Remember, division and multiplication comes before addition and subtraction. So I'm going to do that one next. So 9 minus 4 times 5 is 20. Now, still within the bracket, now I'm going to do that subtraction. That's minus 11. Okay, now, I should change that a little bit. Let's back up. Remember, I don't like to do subtraction, so I like to think of this as 9 plus a negative 20, and that's really negative 11. Okay, now I'm done brackets. So what do we do next? Well, we do any exponents. There aren't any exponents. So multiplication and division. So this subtraction doesn't get done. This is 2 times negative 11. Now, how do you know that's not a subtraction? Well, because of the bracket. It says there's just one number in there, and that number is negative 11. So now, how do you think of this? Is it a subtraction, or is it negative 2 times? And again, it doesn't really matter. If I think of it this way, 7 minus 2 times negative 11, the signs are different, so it's negative 22. If you thought of it as the other way around, guess what you'd get? Well, I don't like subtraction. Think of this as adding the opposite. You might get that. Either way, you'll get the right result. When I add those two, since they're both positives, it gives me a positive 29. All right, so remember your order of operations. Be careful with your rules. Hey, we skipped over one page. What about dividing fractions? So let's go back there and real quick talk about dividing fractions, dividing integers. Cross that out. Dividing integers. What happens when we're dividing integers? Well, if I have negative 20 and I'm splitting them into 4 groups, how many would be in each of them? Well, think of those 20 negative tiles, 4 groups. Guess what? We could make 4 groups of negative 5, since 4 times negative 5 is equal to negative 20. So what would it mean if and again, this is where we kind of fall apart. Negative 20 divided by negative 4? Well, you could think of it as the opposite of what happens when you take negative 20 and make 4 groups, right? Well, negative 20 and make 4 groups is negative 5, but it's the opposite of that. It's 5. Now, is that correct? Well, yeah, since negative 4 times positive 5 is negative 20. Now, as it turns out, when you're dividing, it follows the same rules as when you're multiplying. Negative divided by a positive is a negative, since the signs are different. When the signs are the same, negative 20 divided by negative 4 is positive 5. So signs are the same, the result's positive. Signs are different, the result's negative. Same is true for multiplication and division. All right, go to work.